The vertical continuous plater provides for a continuous process. Panels are processed one at a time through each cell with a constant spacing between panels. Each panel therefore sees the same processing conditions with respect to cell geometry and current distribution. The process consistency and low maintenance are the major benefits provided by the VCP. The VCP may be dual or multi-track in design. The boards are automatically loaded and unloaded. They may be fed either from a metallization process for panel plating or from dry film developing for pattern plating. This technology was conceived by Siemens and is engineered and built by McDermott Equipment. Let's start with the process sequence. Panels are loaded to each track at the load station. The first flood module is the acid cleaner, where the dry film residues are removed with the aid of vibrations. Next, the boards are cleaned in a cascade rinse module consisting of one flood cell and 3 spray sections. The following unit is a peroxide-based micro-etch, removing any film left by the cleaner. We now have a further rinsing step before the boards go to the acid dip. Depending on the specified copper thickness and speed, the total length of the copper cells will be properly designed for each single line. The next station is again a cascade. A pre-dip flood cell is preparing the boards for the subsequent process. The metal etching resist is electrolytically applied prior to another rinsing process and the drying. The last rinsing takes place before moving to the drying station. The drying is based on the IBM Fluid Head patented system. Finally, an automatic handling system will transfer the boards to a buffer station or to the next process. But now, let's go back to the beginning and have a closer look into the details of the line construction. The acid cleaner is a specifically designed soaking solution which is effective with a wide variety of different dry films. The wetting of high aspect ratio holes is guaranteed by the use of vibrations. Temperature, level, and vibration frequency controls are standard features for this module. The combination of flood and spray cells, together with high flow rate pumps, provides the adequate cleaning for the miniaturization of hole size typical of the new PCB technologies. A special clamp rinsing system is minimizing the drag out of chemicals from module to module. The amount of water required is accurately measured by flow meters and is significantly less than in conventional rack plating lines. The temperature, and therefore the etching rate in the micro-etch module, are under tight control in order to ensure the best copper-to-copper adhesion. Like all the process modules, the micro-etch features a separate electrical cabinet for easy maintenance. The level in the sump is measured by sensors and monitored by the computer. The boards go through the acid dip flood cells. The 10% sulfuric acid solution of the acid dip eliminates the oxide from the board's surface for an optimum copper-to-copper adhesion. Toward the copper cells, some horizontal spargers keep the board surface wet and oxide-free until the boards start plating. The minimum possible configuration for the copper cells consists of an input module and an output module. both containing a patented seal system to retain the chemicals within the cell. A special patented diaphragm held at a close distance from the panel on either side serves to guide the panel through the cell and assists with the flow of solution through the holes. These diaphragms operate in conjunction with specifically developed plating chemicals to maximize the macro and micro distribution from the plating machine. Liquid is pumped from the sump into a distribution box, together with air for agitation. The solution and the airflow between the diaphragms ultimately reach the top of the cell, where the solution overflows back to the sump. No anode bags are used in this system, and the anode sludge collects at the bottom of the anode compartments. The high-tech construction of these copper modules features a great number of specially designed parts, such as adjustable shields, spring-loaded cathode copper bus bars, self-cleaning copper titanium anode bus bars, easy-access copper anode baskets. Because of its modular construction, the vertical plater can be specifically designed or even modified according to the customer's needs in terms of throughput capacity and copper thickness. Dosing of the plating additives is accomplished by means of a simple but effective system. Anode maintenance for the VCP takes just 1/10 of the time required for a traditional racking system or a horizontal conveyorized plater, as topping up of copper balls can be carried out while the machine is in operation. The basic construction of the tin modules is similar to the copper modules, except for the anode design. As is the case with copper, the VCP technology allows for higher current densities to be used, which means faster plating speeds. The fluid head patented system provides a fast drying time with optimum results, particularly with high aspect ratio holes and micro vias. In the back side of the machine, the residual tin and copper are chemically stripped from the clamps. In the last part of this continuous process, the clamps are thoroughly cleaned with water. An air nozzle blows off the excess water. A great amount of attention has been paid to the environmental aspects of the vertical plater. The whole machine is fully enclosed to avoid pollution of the atmosphere and to reduce the volume of air extraction. The plater is engineered to diminish the total volume of chemicals used in the process and the usage of rinsing water. The cleaning and maintenance operations are much easier and cleaner than the competitive systems. For example, the anode sludge can be drained easily and directly away to the effluent treatment system, with no need of taking out the anode baskets. All the machine functions, from temperature control to the current setup, to the generation of SPC charts, are computer controlled. Through the computer, the customer can also set the limits for the process. The corresponding alarm will go off automatically if the process exceeds the limits, and is also stored in the computer. High production capacity. outstanding quality performance, easy maintenance, environmentally sound. All these goals have been achieved in the vertical continuous plater, beginning with the right concept and consistently developing it through the engineering and the experience gained over years of production.